Greetings everyone, this is Jeff Wilkerson, Professor of Physics at Luther College, bringing you the next of our What to Look For in the Night Sky series. This time we're talking about the week of March 20th, 2023. Moving right along, hope you had a good week since we last had a chance to talk about the night sky. Hope if you've needed a little bit of precipitation, you got that precipitation, and if you haven't needed it, you haven't got it, and you've had a chance, whatever the case, to have at least a little bit in the way of clear skies to observe. We've had a few clear skies. It's been not a lot of clear skies this spring, but this past week we've had a chance to get out and observe a little bit. It's been nice. So for the week ahead, last week we talked about the moon, trying to get out to see a very old moon, only about 6 or 7% full, as it was near Saturn in the evening sky, in the morning sky, drifting into the sun. Now it pops out on the other side of the sun, and we get to have a chance on the evening of the 23rd. That's Thursday evening, the 23rd. You can go out just after sunset and see if you can find the moon about 5 degrees down from Venus. Venus, the big bright object. We've been tracking Venus. Venus is still in prograde motion. It's still moving east against the background stars, so it's still separating from Jupiter, and we can still see it moving against the stars of Aries that we looked at last week, and the stars of Pisces below it, Cetus below it, that we didn't talk about last week. And so, but now, on the evening of the 23rd, the moon is only going to be about 5 degrees west of Venus. So you can go out and you can look for the moon, and it's going to be about that 7 degrees full again. So we were looking for a very old, very thin crescent moon, and hoping we could find Saturn in the glow of the sun last week. This week we can use a very new thin crescent moon to see if we can find it below Venus as it's popping out of the glow of sunset. One night later, it will have moved from about 5 degrees west of Venus to about 7 or so degrees east of Venus, and it will have gone from 7% full to maybe 13 or 14% full, depends on when you're looking at it, where you are, and that's angular separation, of course. So one night later, on the Friday the 24th, we can look for the moon to have filled out. If it's a challenge to see a 7% full moon, it's worth it. But if it's a challenge to see a 7% full moon in the glow of the sun, it should be pretty easy to see a 13% full moon. And now it'll be sort of above Venus, if you will, as they're sinking down into the horizon in the west. And so that's great. That's something to observe. One night later, it will have moved up. The moon will have filled out to over 20% full, 22, 23% full, something like that. Again, depends on when you're observing it in the night. And it will be sitting just a couple of degrees, 2 degrees or so below the Pleiades, beautiful star cluster. It's not bright enough. The moon's not bright enough at this point to have washed the Pleiades out much. And the Pleiades is one of these things that we can observe that holds up to a moon pretty well. So this is going to be a fabulous pairing. If I were going to go out one of these nights, and only one of these nights, I'm going to go out the one that's clear, obviously. But if I have all of them clear and I only have a chance to get out one night, I would probably go out to see the moon below the Pleiades on the 25th. That's all the way to Saturday, toward the end of the week. So this is a great thing to be out there trying to observe. So enjoy the moon there with the Pleiades. The Pleiades, remember, is an open star cluster. It's a star cluster that lives in the disk of our galaxy. If our galaxy looks like a fried egg, like this, the Milky Way, here we are, and this disk, this flattened disk of the Milky Way, the bulge is probably bigger than that, the flattened disk of the Milky Way, it contains all kinds of open star clusters, globular star clusters that we look at from time to time, live in a halo around the center of the galaxy, so we have to look this direction to see the globular star clusters. We can look in all directions because we're sitting in that, if you tip this up, right, we're sitting in this disk, and we can look in all directions of this disk to see the things that are in the disk. And so we can look in all directions to see the open star clusters. But they are the hazy band. This disk right here is the hazy band that we call the Milky Way when we look up in the sky. And so we will see more of them when we look near that hazy band. Like, for example, if we're looking this direction, we are looking down toward the center of the galaxy. We have a lot of that disk of the galaxy to look through, a lot of open star clusters in that direction. Likewise, if we look this direction, toward the anti-center of the galaxy, a lot of open star clusters to see out that direction. Not as much stuff, because there's more stuff toward the center of the galaxy than away from the center of the galaxy, but there's plenty of star clusters to see, and it's worth doing. And we're kind of looking that direction now with the Pleiades. We're looking more that direction if we move on up here to Auriga. And Auriga, let's draw it in. I've busied up the board like I like to do. I like to make a challenge for you, right? I don't want to make your life too easy. And so I've busied up this board to the point that you can't really see anything. But if we connect the dots here, we've got Auriga that looks like this with the bright star Capella up here in Auriga. The two stars that are down here moving up from the Pleiades, we move up this direction, we come to Iota and Theta in Auriga. These two stars right here. Now Thetas, they're both about 2.5 magnitude, 2.6 magnitude, I think I wrote on the board there. So they're good, easy stars to see. All the stars that we've marked here, Capella's a big, bright star, color kind of similar to the sun, great star to observe. So all of these stars of Auriga are pretty easy to see. But Iota and Theta we're looking at here because they're sort of on a line from the Pleiades up this direction. Theta is an interesting star. So we'll work on that this week. We'll say, okay, let's enjoy the moon sliding by Venus and going to join the Pleiades as it fills out, and then enjoy the view of the Pleiades, and then we'll come up here and say, let's learn Iota and Theta in Auriga. Let's spend a little bit of time observing them and enjoying them this week. Theta, if you've got a small telescope, Theta is a pretty good binary star for that small telescope. You got a star, the bright star that's about 2.5 magnitude, and then you got a faint star that's down about 7.4, but that's not that faint. It pops in a small telescope pretty well. But the brightness contrast is very good with this binary star. They're about 3.5 arc seconds apart, so that's also a pretty good separation typically to be able to see in a small telescope. So it's a pretty good pair of stars. And there's a third star that looks like it's part of the system, about 50 arc seconds away from those two stars, but it's just a chance alignment. It lies not with those two stars. And so you've got the third star that's pretty in there with them, but you're looking for this as the binary stars. Those will be real close pairing. A nice double star to look at, a nice binary star to look at that direction. But now as you've tracked from Iota to Theta, you've got three more really nice open star clusters. You got M36, M38, and M37 right across here, pretty close together, that stretch across this line that connects, or just down from this line that connects Iota to Theta up this direction. So you got your telescope out to look for this binary star. Check out these open star clusters. It's worth it. I think M37 is probably the best of those, the richest, the most beautiful of those. Try them with binoculars. You might see them as hazy patches with binoculars. With binoculars, you'll be able to see the Pleiades really well. You can see the Pleiades with your naked eye. You don't need any optical aid whatsoever for that. So you've got this group of open star clusters. Now, as you're looking at these open star clusters, you're turning to look this direction. This is the anti-center of the galaxy. You got your back toward the center of the galaxy, looking directly away from the center toward the outskirts of the galaxy to see these open star clusters. So think about that as you do that. Beautiful thing about this time of year, remember, we're seeing this just after sunset as we watch the moon pull out and Venus pull out of the glow of sunset, and we scan on up. So we're looking at this in the evening sky shortly after sunset. You know, this is far enough north for those of you who are mid-northern latitude observers like myself. This is far enough north that you can see Auriga well into the night. But in any event, we're looking in the evening sky to see this. If we wait until morning and look just before sunrise in the east coming up, we're going to see Sagittarius and Scorpius. And so what's happened is the Earth has rotated. In the evening, we're looking this direction. It's rotated all the way around. Picture that rotation of the Earth all the way around to look back this direction and see Sagittarius and Scorpius in the center of the galaxy. So this is good, the direction of the center of the galaxy. So this is great stuff. Good, beautiful open star clusters to see. Of course, there's a lot of beautiful open star clusters in the direction of Sagittarius and Scorpius to see, but really just to think about right now, you go out in the evening and you look at the night sky, you look a little bit west at the night sky, toward the western horizon a little bit, and you're looking in the anti-center of the galaxy, you wait until morning, or go get a little sleep if you want to, if you must. Go get a little bit of sleep and get up in the morning, and you're looking, but we've rotated around so that you're looking toward the center of the galaxy. So we got good stuff. Hope you have a great week, everyone. As always, thanks for watching, and please join us next week for something new to think about and to look at.